not going to be used there. Are there any x values we're not going to use? Because this black line is going to go on forever. So 0, that's a good question. When x is 0, y just happens to be 3. That's a point right there. That's 0, 3. So I'm going to go ahead and just ruin this for you possibly. You are going to use every x value from 0 to positive infinity, from 0 to negative infinity, 0 included. You're going to use all the x values on this Cartesian plane or this graph. So when we write down the domain for something like this, there's a couple different ways we can write it. We can write the domain as all real numbers and all real numbers, if you remember back to, I guess it was unit 2, we talked about real numbers, the real number system. As long as we have a real number, it's going to be there. So the domain is going to be every x value from negative infinity to positive infinity. That line's going to go on forever. It'll hit every x value there is. Hopefully that kind of makes a little bit of sense. I'm going to show you a different way to write it. You can write it as all real numbers. You could also write it as a set inside some brackets. So we could go from negative infinity to positive infinity. That could be the domain. Fake numbers, I didn't really talk about, there's something called complex numbers or imaginary numbers. Imaginary is not a real great word to describe it, but when you start dealing with the square root of -1 in math, we call it I. And we have a whole another set of math principles dealing with the square root of -1 because the math works out when we start dealing with square roots of negative numbers, which is just kind of a really bizarre idea. But it explains lots of phenomenon in our everyday lives. So they're actually called complex numbers or imaginary numbers. And we do deal with them from time to time, but that is not included on this graph, so we don't have to worry about it. Or included in high school, really. Maybe grade 12 math and physics, you might run into imaginary numbers, but probably not. The last one I'm going to write here, I've run out of room, but I'm going to put it down anyways. Maybe I'll write it over on the left. This is kind of math, a shorthand, mathy speak. You might see it. It comes up from time to time. And we're going to go with this. We're going to write x, because when we write our domain, we're talking about x values. Then we're going to write a c, and then we're going to put a little line in the middle of it. I don't really like that c very much. Like that. It's kind of a weird thing, kind of looks like an e. And then we're going to draw an r. Instead of it being a regular r, we're going to just extend the top and give it 2 lines. And you're thinking like, Mr. Borden's lost it. It's kind of like Transformers when Shia LaBeouf starts seeing all those crazy symbols in his head. That's exactly like this. But this is, in math, we use Greek letters to represent words, essentially. So what this means is x, this guy here is contained, and then this fancy r is real numbers. So what this means together is x is contained in the real numbers. And that is another way of writing down that your domain uses all the x values possible. It comes up enough that mathematicians have decided that this is going to, represent that sort of thing. Are they called imaginary numbers because they can't be represented by something physical? I'm not sure where imaginary came from. A more correct term is complex, because imaginary sounds like this airy fairyland where you're dealing with all these strange things. So I'm not sure where imaginary came from, and I don't want to even make it up or take a guess at it because I just don't know. But they're generally in mathematical circles called complex numbers, and that's what they are. So there's lots of information. It's definitely an idea that grade 10 you could understand, but we just don't bring it up until grade 12. just because it gets a little trickier. Back to domain and range. I really want to get through this stuff, and it gets a little bit trickier. All right, so those are 3 different ways to represent x is contained in the real numbers, or x is all real numbers, or x goes from negative infinity to positive infinity. They all mean the same thing, and they are kind of interchangeable. So the next thing is range. And when we talk about range, we're talking about the y values. So are there any y values that we aren't using on this graph? So I'm just going to erase all this stuff off my graph again and think about y values. So my y values are on my vertical line here. Those are all my y values. So is there anything that y is not using? I'm going across there, I'm going across there, I'm going across there, there, back to the y-axis. Are there any y values I'm not going to use? It turns out that I'm using all of my y values as well, because this line is going to go up, up, up forever and down, down, down forever. I'm going to encounter every single y value. So y is going to look really similar to x. We could write something like all real numbers. Or we could write y is contained in the real numbers. Or we could write from negative infinity to positive infinity. All of those would work. Imaginary numbers sound interesting. Could you answer with any of those on a provincial? I'm not sure what you're kind of getting at there. The provincial exam might have a question like, identify an irrational, or no. I don't think you're ever going to have to encounter it in terms of grade 10 math, because the IRPs, the things you must learn in grade 10 include stuff like the real number system. The IRPs, or the curriculum, if you will, says nothing about imaginary or complex numbers. So they couldn't ask anything about it because it's not included in the curriculum that needs to be taught to you. I don't know if that answers your question, but I mean, any of the ways of writing all real numbers as an answer. Oh, yeah, sorry, I was confused. Is there any, would it come up? Yeah, it could, I guess. If you had a graph like A on the provincial exam, and they said, what's the domain? And they gave you a bunch of answers. They could write it in different ways. They could write it as words, all real numbers. They could write it as an ordered pair set, like negative infinity to infinity. I'm thinking that the x is contained in the real numbers, the mathematical notation, probably won't come up on a provincial exam, but it will be something you need to know moving forward in math. So it's worth seeing it now. You might encounter it again. All right. Letter B. We have a horizontal line. All right. The domain is the x values. I'll just write it right up above it, x values. What x values is this graph using? So if I want to think of it this way, if I take a point here, I drop it down, it's using that x value, it's using that x value, it's using that x value. That line is using all of these x values, so literally everything along here and same deal along here. All of those x values are being used forever, in every direction, going on both directions, negative and positive, to infinity and beyond. So the x values being used by this graph are all real numbers, or x is contained in the real numbers, or negative infinity to positive infinity. Yeah, so we're going to the right forever and to the left forever, because the arrow there, or the line I should say, have arrows on either end. So it's going in either direction forever and ever. How about y values? What y values are being used by this graph? And this is where this domain and range stuff gets a bit tricky. Am I using this y value right here? Am I using this y value down here? Am I using this y value down here? Am I using any of these y values in red? Turns out that the graph, this line, this black line, isn't using any of these y values. It's using nothing down here, and it's using nothing up here. What y value is it using? Now, there's no numbers written on this, but I can assume each little graduation on my graph is 1. So there's 1, 2, 3, 4. And this is 5. So this is y is equal to 5. So what y value is my graph using? Remember, the range is the y values. In this case, y is equal to 5. Anything else? No, just 5. That's it. It just uses one y value. The graph, the line, the equation of the line is literally y equals 5. It's just saying y is 5. So that's going to go horizontal. Horizontal lines can use all your x values, but it's only going to use one y value. In this case, it's 5. I could write it as y equals 5, or I could write it as a 5 in square brackets. So these are all different ways of representing this. Function, I didn't even see this function thing. Is this a function? Yes, it passes the vertical line test, and yes, it passes the vertical line test. So that is that. All right, letter C and D, these get a little bit trickier. Once you kind of understand the ideas behind domain and range, we have to throw in some like bizarro things to kind of test if you really know it. So we're going to use this sort of thing with a dot and closed dot, open dots. I'll talk a little bit about them. Why so many brackets? They all represent different things. Curly brackets are sets, square brackets means including, round brackets means not including. It's just notation. Mathematicians don't like words, so we need to come up with things to represent words. So we, instead of saying contains, we write a C with a line in the middle, or real numbers is an R with 2 lines next to it. And it's just one of these things. I don't know if mathematicians are lazy or maybe efficient, maybe a bit of both. All right. This is kind of the opposite of what we just looked at. So the domain is the x values. In this case, what x values are being used? So it looks like I'm not using any x values over here. I'm not using any x values over here. The only x value I'm using is -3. So that's the only x value. I could put it in square brackets. It means including 3. How about my y values? What y values am I using? The line kind of just starts in midair and then goes up. So when I'm thinking of y values, I'm not using any of these y values down here. Anything going down forever, I'm not using. This line is only going up. It's not going down any further. So in terms of my y values, it kind of looks like it's between these 2 points on my graph. So this looks like -3 and -4. If you want to think about drawing a line across your graph, I'm going to use all of these y values up here, all of these, all of these, all of these, but once I get down to there, I'm not using any more y values. So these ones are all included, going up forever, and then anything below that is not being included. So what are my y values? And you guys already know a way to represent this, and it's going to maybe be a bit goofy to see it in this context, but my y values. My y values are all going to be greater than or equal to -3.5. As long as my y is bigger than 3.5, it's going to be included. No y values are going to be any smaller than -3.5. I'm not using anything down here, So all my y values are going to be bigger than 3.5. What's the difference between a filled in dot and a not filled in dot? That's a great question. We'll talk about it in the next example. There's one different way I can write this y thing. I can write it as a square bracket, negative 3.5, and then infinity with a round bracket. The square bracket means includes, the round bracket means does not include, but it's going to infinity, so it doesn't really matter. The y values go from negative 3.5 to infinity. Is this a function? No. All right, so Alex picked on something in the next example here. In letter D, we can see that there's a closed dot and an open dot. And a closed dot means it includes this point. And the open dot means does not include this point, which is kind of weird, but we'll go with it. So, x values, domain. If I think about it in terms of my graph here, I'm using all of these x values from here to here. So I need to figure out what my smallest x value is, which is going to be right here. I need to figure out what my largest x value is, which is going to be right here. And then I can go from there. So if I count on my graph, this looks like negative 5, and this looks like positive 5. So all of my x values are going to be between negative 5 and positive 5. So I'm going to write this like this. Negative 5, and then positive 5. I'm going to put my x between those things. And this is kind of more notation. This is kind of why domain and range gets really difficult, because there's lots of notation involved. My x values are all going to be, if I ignore for a second this plus 5, I can say that all of my x values are going to be greater than or equal to negative 5. Are we happy with that? Going back to the greater than or equal to stuff that you learned, I don't know, probably grade 8 or something like that. So my x values are going to be greater than or equal to negative 5, but they're all going to be less than positive 5. I could put positive 5 if I want, but I'll just put 5 generally. So all of my x values are going to be between negative 5 and positive 5, and we're going to include negative 5, but notice I didn't put the greater than or equals to on this guy because I'm not including this positive 5. It's not including the 5, so does not include is that open dot. Yeah, so just, you were right with the less than 5, but you just, not that less than or equal to. All right, so those are my x values. I can also write that as this. I can write it as negative 5, comma, positive 5, and I have one square bracket, which means includes, and then a round bracket means does not include. And again, just notation. Those are two ways of writing the same thing. The first way I wrote it's probably a little bit more common than the second, but you should be aware of both. Range, the y values. Let's see if I can get another highlighter here. My y values are going to be everything along here. So these are all the y values I'm including. So what do my y values look like? So what is the largest y value I'm using? My largest y value is 1, 2, 3. That's 3 up there. My smallest y value is negative 4. So my y's are all going to be between -4, and 3. Am I going to include the -4? No, because it's an open dot. But I am going to include my 3 by going less than or equal to 3. And I can write this in terms of the other fancy notation as I'm going to do a round bracket here because it's not including -4 all the way to +3. Because it's including +3, I use a square bracket. And this is a function. It passes the vertical line test. Why bother writing not including 5 instead of just writing less than or equal to 4? We have all the values between 4 and 5. I have 4.1, 4.2, 4.3, and those are all not included. So kind of run into some problems with that. I know what you're thinking. You're like, oh, we're just dealing with whole numbers. But if you really think about it, we can break up that little space between 4 and 5 into literally an infinite number of pieces. I can say, 4.222222 and on forever, and that could go on forever. And I could go 4.3333 or 4.3127 or whatever. It just can go on forever. So we don't want to kind of fall into that thinking trap. So if the circle's on 4 and it's open, then it's getting as close to 4 as we can get. So 3.9999999 on forever, but it's never going to equal 4. A weird math idea, I know, but that's the way it is. Okay, I have about 7 or so minutes, and I want to fly through these last ones. I know there's a whole schwack of them. Maybe I'll do question 2, and then I'll get you guys to do question 3 for homework, because there's not a ton of domain and range stuff in the learning guide. There's a bit, but not a lot. Okay, so domain and range. I want you guys to try A. I want you to see if you can come up with the right answer here. Think about the x values, the largest x value, the smallest x value, and then think about the y value. So as long as you can get the numbers and the notation in the direction of the less than or equals or the round brackets, close brackets, if that doesn't make sense yet, that's fine. The important thing right now is that you can recognize the x values that this little line segment is using. What's the biggest x value? What's the smallest x value? And then what's the largest y value? And what's the smallest y value? And just write them down. Don't worry about the less than or equal to's and all that jazz. So I'm going to give you a few seconds to do that one. If you want to go on and try B as well with the open dots, you can, but if not, that's fine. Just stay with me. Okay, letter A. I'm looking at the largest x value that's included in the smallest. And sometimes it makes more sense to start with the smallest and then the largest because we write from left to right. But anyways, the smallest x value I'm using is right here. So this is -1, 2, 3, 4, 5, 6, 7. There's -7. My largest x value is right here. So that's 2. So I'm going from -7 to 2. All of the x values, -7, -6, -5, -4, -3, -2, 0. And then I got 0, 1, 2, and then everything in between them because it's a continuous line. So I have all of these x values from there to there, forevermore. And I have closed dots, so I'm going to include those. So my smallest is -7, my largest is 2, and my x values are between -7 and 2. All of my x values are going to be greater than or equal to negative 7, and all of them are going to be less than or equal to 2. So that's one way I could write it. I could also write it as a set from negative 7 to 2, including negative 7 and 2. So square brackets. So those are my x values. My y values are going to be, there's my largest y value, there's my smallest. Negative 1, 2, 3, 4, looks like negative 5. 1, 2, 3, 4, 5. So I'm going from negative 5 to positive 5. My y values are going to be less than or equal to greater than or equal to negative 5, less than or equal to positive 5. As a set, negative 5, positive 5, square brackets. So they might start with the higher number. You could, if you wanted, to start with the positive number first, but then your greater than signs would just have to flip over. So they'd just be opposite of what they are. So although we probably wouldn't write it this way, we could go 2x and then negative 7, and then it would be all of our x values are going to be like that. Does that make sense? Yep. So x would be between, so we can greater than, less than, like that. But generally speaking, we always go with the negative to positive. All right. I'm going to do B, C, and D real quick because I have run out of time. X values. X value is here, my other x value is here. So this looks like negative 1, 2, 3, 4, 5, 6. And this looks like 1, 2, 3, 4, 5. So my smallest is negative 6, my largest is 5. I'm dealing with x values. I'm not going to include the equals because they are open dots. And when I write it, I'm going to write it with round brackets. When I'm dealing with y values, my smallest is going to be down here. Negative 1, 2, 3, 4, 5, 6, 7. So I have negative 7. And then I have 1, 2. So everything's going to be between negative 7 and 2, round brackets. Not square brackets because I'm not including those. These are both functions. All right. I'll do these two and then we'll call her a day. Yeah, this one's a little bit tricky in terms of x values because my x value here, let's assume it's on this line. That's my largest x value, but it just goes on forever in terms of negative x values, which is kind of strange, but that's just the way it is. So my largest x value is going to be positive 3. So all of my x values are going to be less than or equal to 3. I don't have anything over on this side because I'm going to deal with every negative value. So just everything that's less than 3. That's it. If I wanted to write that as a set, I could go negative infinity to 3. And I could write it like that. My range, my y values are kind of going to be similar. My largest y value is here at 1, 2, 3, 4. So all my y values are going to be, is that 4 or 5? 1, 2, 3, 4, 5. Sorry, it's 5. So my x I've done. My y's are all going to be less than 5. And I can write that from negative infinity to 5 I could put some square brackets on it like that. Fortunately, I've run out of time for the rest of them, so I'll go through them next day. I guess you can consider this homework. Try D, question 3, and then the last page asks you to draw a few of your own. Just draw a random line on a page and see if you can figure out the domain and range. So these ones are the same, but they're just non-linear, meaning they're not straight lines. The learning guide, graphs, you should be able to do that. I'm just looking for domain and range stuff on here. Yeah, so there's some domain and range as the last couple questions there. So we should be able to do everything in the learning guide now on that first part. So I broke the learning guide into 2 parts. I'm hoping you can hand in the first part tomorrow at the end of class. And then I've opened up the second part for you guys to print off for tomorrow's class. So I know this is a bit of weird stuff and you've never seen it before. We'll spend some time talking about it next day and then we'll talk about the next lesson as well. So hopefully you guys have enough of a foundation to get a little bit of it done. Just do your best and get that done for tomorrow. So thanks guys, we'll see you tomorrow. There's no English today, Mrs. Ward and Wood are gone. And I don't think there's English tomorrow as well. So I'm on at 10:30 tomorrow because I have another class in the morning. That's why we're not starting first thing. So we'll see you guys tomorrow at 10:30.